Hey everyone, this is an instructional video for the Logic Playground. This is a new product for Thinking Hertz, and this is based on the blog series Logic Noise by Elliot Williams. You can find it on hackaday.com/tag/logic-noise. This is the first 3 entries in the series, and this board was sort of designed as a workshop. So this is sort of, building this board is the second part of the workshop, where the first part would be building these circuits on a breadboard. And so this is designed to work with breadboard patch cables. And these plug right in, and you can interface directly with a breadboard or with external audio. First thing I'm going to say is that this board uses a 9-volt battery as the power supply, and I'm running this output into an amplifier. These circuits will not drive headphones directly, so you might want to run this into an amplifier to hear the individual oscillators. But I'll just sort of walk through how this board works. So first thing is we have this chip, the CD4106, and this is an inverter chip with 6 oscillators. 1, 2, 3, 4, 5, 6. And they correspond to these 6 capacitors. And how this chip works is the larger the capacitor, the lower the frequency range. So I'm just going to listen to these 6 capacitors. I'm going to plug this into my output, and I'll plug this into oscillator A. And B. C. D. E. And F. F is my largest capacitor, which allows me to get these very slow square wave pulses. And because of this, for F, I can use this as a low frequency oscillator. So what I'm going to do is I'm going to remove this from the output, and I'm going to interface the 4106 with these other 2 chips. So the first chip I'm going to interface with is the 4040. This is a frequency divider. And so I want to be able to see how fast my clock is. So I want to be able to run this into both the clock and to an LED, just so I can see visibly the clock in both places. So down here I have a multiplier. This just allows me to split the signal. So I'm going to do that first. Run my clock first into the 4040. And I'm also going to plug it in to this LED. So now we can see my original clock speed here as I change this. I can't hear it, but I can see it get faster and slower. Okay? So how the 4040 works is we have these divided outputs, and these take my input clock and divide it by 4, by 8, by 16, etc. So I'm just going to demo this on the other LED so you can kind of see. Here's my clock divided by 2, divided by 4, divided by 8. So this is useful in modular synthesis if you want kind of syncopated patterns that are in time with each other but running on different clock speeds. So I really like this chip just by itself, just so I can get some different outputs out of my input clock. But what I'm going to do, which I think is the most interesting thing, is interface with this chip. This is the 4051. And this is probably the most complicated chip to understand, but I think it sounds the most interesting. This is an analog switch. I'm going to remove that cable. And how this works is I have 8 pins here. And then over here I have A, B, C, and X. X is my common pin. And X can get connected to any of the other 8 inputs. Okay? So I'm going to hook up X to my output. Now, the pin that X is connected to is determined by the binary number on A, B, and C. So this is how binary works. If none of these have a voltage, 0, 0, 0, X is going to be connected to pin 0. So if I hook up an oscillator to 0, that's what I hear, X connected to 0. I'm going to pop this into 1. Now, in order to get X connected to pin 1, I need to have a high voltage on the A pin, 0, 0, 1, okay? The interesting thing here is instead of just putting a 1 or a 0, a voltage or no voltage on this pin, I'm going to put in a clock. And this allows me to get sort of a rhythm going here. Remember, this is half the speed of my clock that you can see up here. If I move this down one, that's half the time. That's even slower. So what's happening here is X is moving between 0 and 1, right? Because this is either 0, 0, 0 or 0, 0, 1. So the interesting thing I can do here is I can put 3 clocks into this to create sort of a random but repeating pattern of binary. And then I can put any audio inputs into these 8 pins, and X will get connected randomly to those pins. So I'm going to start with my first clock. I'm just going to pick another clock randomly. And kind of a third clock. Now, the slower the clock, the longer my sequence is. Now I only have one oscillator plugged into 1, so let's patch in a couple more oscillators and see if we can get something interesting. And of course, all of these are tunable. And I can change my master clock. I can easily change this pattern just by moving the clock around. And I can change what step these are on by just sliding these to another number. So that's it. I hope you like the board. I think it can do some interesting things. And yeah, please visit our website, Thinking Hertz. It's thinkinghz.com.